The following video tutorial will demonstrate how to explore and analyze data when using a two-way ANOVA and how to use R to gain statistical results. For this example, we are given a set of data where our subjects are people who graduated from university 5 years ago. We are given their gender, what course they studied, and their current earnings to the nearest pound. Our aim is to understand the significance of the effect gender and course have on earnings. Before we begin to explore our data numerically, we need to look at what variables we have and what type of variables these are. We will use the following table to help us. The first variable we will look at is earnings. The first column asks us whether it is a response or predictor variable. It is clearly a response variable, as in this survey we are asked to see if earnings responds when course and gender change. The next column asks if our variable is categorical or quantitative. Earnings is a quantitative variable as it has a clear natural numeric order. The final column can be ignored as earnings is a response variable. The next variable we have is gender. Gender is a predictor variable and it is a categorical variable as it has no natural numeric order. It has two levels, male and female. Our final variable is course. Course is also a predictor variable. It is categorical for the same reasons as before, and it has four levels: maths, engineering, sports science and geography. Now we have an understanding of our variables, let's transfer our data into R so we can carry out some exploratory analysis. To do this, save your file as a CSV file and use the following code to upload your data. You can see here I'm using a Mac and therefore the interface is slightly different to Windows. However, the coding language is exactly the same. The only aspect that will differ if you're trying this yourself is the directory between the quotation marks. Remember, in Windows you need to change the backslashes to forward slashes. It is useful at this point to split our data into two subsets, one containing all the males and the other all the females. This will make coding easier in the analysis that lies ahead. The coding for this is shown here. We have changed the column names so they are different to our original data. Otherwise, R may not know which set of data you're referring to. Notice in the R code line labelled number 5, instead of using the column names course, gender, earnings for the male data, we have used course.m, gender.m and earnings.m. Similarly, this has happened for the female data, where we have used .f. You can see here when I run the command, I now have two sets of data, one containing the males and the other the females. We want to start by carrying out some exploratory analysis. This will give us a feel for what our data says and help to determine whether we are on the right track for our plan for analysis. We will not, however, draw any conclusions during this process. The techniques we will carry out will include comparing means and standard deviations, constructing side-by-side box plots to get a sense of how course and gender independently influence earnings, and an interaction plot to assess how gender and course together relate to earnings. To compare means and standard deviations, we use the design matrix as shown here. In each cell we will input the sample size, the mean and the standard deviation. So the first cell here will have the information for male engineers, this cell here will have the information for female mathematicians, etc. The following R code will calculate the mean and standard deviations for each cell. Here we can see all the means and the standard deviations. The first line of R code gives all the means for males in different courses. The next gives the means for females, and the following two give the standard deviations. So for example, this value here gives a standard deviation for female mathematicians. Inputting this into our table gives the following design matrix. If we compare means, we can see they do not vary much between genders. For example, in engineering, the difference in means is only £400, which is not substantial at all. However, there is a much larger difference in means when moving from course to course. This is shown by the difference in means from engineering to geography, which is £13,000. This is something we will look out for more in our later analysis. Standard deviations are on the whole quite similar, apart from male maths, which has a considerably higher standard deviation. We need to be cautious of this in later analysis, as some tests assume that your highest standard deviation should not be more than twice your lowest. To get a more visual feel for our data, we construct side-by-side box plots. We will first construct box plots for gender. This can be done using the following R code. These box plots are very similar. Both males and females had medians of around 37,000, and they both have similar upper and lower quartiles. It would not be surprising if we find no significant differences when we come to carry out our analysis later on. Now let's look at the side-by-side box plots for courses, shown here. From course to course we can see very different amounts of earnings. In fact, the highest paid geographer, which is not an outlier, earns less than the lowest paid engineer. We would expect to see some sort of significance amongst this data, provided our sample is large enough. We have looked how our predictor variables may behave independently. The final part of our exploratory analysis looks at how they behave together. To do this, we construct an interaction plot using the following code. The dotted line shows change in mean earnings for females between courses, and the solid line represents a change of mean earnings for males between courses. For geography and engineering, they behave quite similarly. The only real difference occurs between maths and sports science. In maths, male graduates earn considerably more than female, but in sports science, females earn more than males. This suggests that gender and course may be related. We won't know if it is a significant relation, though, until further testing. We will finish our exploratory analysis here. Here is a conclusion of what this video has shown. We identified and categorised our variables. We transferred the data into R and split it into two subsets, male and female. We constructed a design matrix which allowed us to view the sample size mean and standard deviation of each of our levels. We constructed side-by-side box plots which allowed us to explore independently how our predictor variables affected our response variable. And we constructed an interaction plot which allowed us to explore how our two predictor variables act together on our response variable. Now our exploratory analysis is complete, the next video shows us what test to use given what we have done here, and it will calculate p-values to see if any of our predictor variables are significant.